In R, what we do is not just clean the data, we also wrangle it into submission. So today I'm here to introduce you some ways to wrangle the data for a dataset. And what we do here is data wrangling. It's also the art of taming chaos. Okay, first let's see why we need data wrangling. Because in your raw data, you may have some typos or nonsense values like -999 or NA values that are the values we don't want, and they should be replaced by other specific values, or using other methods to replace the outliers later. I will introduce you. Besides, you may also have some columns to be split. And finally, you may also have some rows to be filtered or split. Like you may consider about split your dataset into the train rows and test rows, especially for the machine learning or big data, big model. So here I'm going to introduce you the package in R named as dplyr. The package dplyr is one part of the larger tidyverse package that enables you to work with data in tidy data formats. And tidy datasets are easy to manipulate, model, or visualize, and you will be more familiar with them as we dig deeper in R. Have a specific structures. Each observation is a row, each variable is a column, and each type of observational unit is a table. So the package dplyr provides convenient tools for most common data manipulation tasks. It is built to work directly with data frames, which is one of the most common data formats to work with. Okay, first we're going to use the function, the selecting column function and filtering rows function under the dplyr package. First, you need to do what? Yes, let the R know that you are going to access to the package. So the function should be library package named as dplyr. Always remember that library the package before you use the function under it. Then we need to load our data. How about we name it as my data and use the function I introduced you in the last video. Here I need to copy and paste path of the dataset using the quotation mark. After it should be the CSV file name, and then run it. So for a quick look of your data, you need to use the head function. How about we show 20 rows of it? And here you get the first 20 rows of your dataset, my data. Another way to look at into your data is directly click the variable name my data in the environment window and click it, and you will see the whole table of your dataset for all columns or rows, and you can see that there are many NA values which should be tackled with later. And then what if you want to select several columns from your dataset to analyze later? For example, you are interested in the artist inverted, the first week, the second week. We're going to use the select function under the dplyr package to select the specific columns of your dataset. How about we name it as selected columns. Here you're going to use the select function. It would hint you that the first position of this code should be the dataset name, namely my data. If you leave the other parts unchanged, the selected rows dataset would be the same to my data. But if you are going to select the specific rows to form the new dataset, you're going to type the specific column name, like artist inverted. But you will find that it would be difficult for you to remember the name and type it again in the sentence. So I would introduce you an easier method. You could use the column names function to show all of the column names of your dataset like this, and then you would just copy and paste the specific columns you're interested in. There won't be any typo, as you'll remember. It might be wrong. Copy and paste the first and second week, this one, and second week, and then run it. So you would see there are only 3 columns here. Sometimes you are going to select all of the columns from the first week to the last week value, like the 76th value. It would be difficult or time consuming to copy and paste all of the column names here. So how to do this? You could keep the data, the original data, and keep the artist column and choose the first column to the last column using this colon mark. Again, this we also name it as my data selected columns, but this time I'm going to use the column mark to select the column values from the first week to the 76th week. So let's see what will happen. Run it, and my data selected columns would be formed from the first week's value to the 76th value. In addition, sometimes you are going to select the columns based on their names, like you are going to keep both these 2 columns named starts with the date, the data entered and data peaked. So what you can do here is introducing data start with. Again, you want to keep this one and starts with date. So let's run it and check it. Here are 3 columns you specifically determined to keep. So they are artist inverted. The 2 columns are started with date. And you can also use the end with, like you're going to keep all columns end with week. So you can use this function and change it to end with week. And in the new formed data, the columns are kept based on their ending words. There is also other ways to, for example, you can choose words that contain something using the argument contains. Like you want to keep columns that contain the period mark. Use this. In the newly formed data, all columns are selected based on the shared same period mark. Here are the ways how we could select the specific columns based on the specific criteria.